In this video, we'll be going through a few design guidelines you should be aware of if you'd like to do some CNC milling at FabLab. Firstly, we'll talk about the different sorts of geometry used in your files that you'll submit to FabLab. Basically, all sorts of geometry that you can create in CAD programs can be used to inform different sorts of toolpaths and different sorts of effects that the router will create. For example, a collection of points can be used to describe drill holes. Curves, both open and closed, are mostly used to describe profiling cuts and also engraving lines. Surfaces are used for 3-axis milling operations like parallel finishing. This is the same for poly surfaces and meshes. If you're modeling topography, there's a good chance you'll be working with meshes. There are a number of factors that will influence the ability for all these geometries to be milled successfully. Firstly, the CNC router at FabLab has a maximum bed size of 2.4 meters by 1.2 meters. This doesn't mean that you can mill things exactly this size. You need to work within an offset border of 20 millimeters to ensure that we can mill your geometries successfully, but more importantly, safely. The absolute maximum height for our CNC bed is also 200 millimeters. Your geometry needs to be large enough to withstand the milling process. Any geometries down to around 100 millimeters long/wide can be milled quite successfully. Geometry smaller than that, down to around 25 millimeters, can be milled successfully, however, bridges are needed. Let's talk about them now. Bridges are small areas where the part isn't cut all the way through. This means that the part will still be able to be produced by the router without flying out and killing the operator. Any geometry smaller than this size is pretty impossible to mill and has to be created in another way. Further to this, the taller your geometry is, the thicker it should be to be milled successfully. Geometries of this size are much easier and stronger compared to geometries like this, which are a lot shorter and slender. There are no real measurements about what can or cannot be produced. It's best to talk with the fabricator at FabLab to see. The geometry to be milled must be able to be reached by the router bit. On a 3-axis router, this means that anything viewable in plan can be processed successfully. Geometry with this sort of undercut detail needs to be either flipped around or made in a different way. An example of this can be shown on this part. This part has an undercut detail that can't be easily milled by the router, and this white cylinder is representing the router bit. The best thing to do would be to first cut it out in this direction and then flip it over and mill out this channel. Alternatively, this geometry can be broken apart, have this sort of notching detail added so the whole piece can fit together. This sort of undercutting stuff isn't for beginners, and if you think your project requires it, come and talk to us by booking a consultation with one of our technicians.
Go.
Video 4. Oh hey, so that was basically the whole entire CNC process. In the next few videos, we'll be talking about some of the restrictions you'll have to follow, like geometry restrictions in your modeling, so you can get the best result the first time, every time. That was